props here, and we're going to take a look at number 2 on the quadratics test that we had last. This is one that people seem to have a hard time with. So the equation is x squared minus 2kx plus 1 equals 0 has 2 distinct roots. Find all values of k. That's the key, 2 distinct roots. It's not asking for the roots, it just wants to know what values will make them have 2 distinct roots. Well, the thing we have to deal with is the discriminant, which we know, let's turn on my pen, which we know is b squared minus 4ac. Well, in order for that to be 2 distinct real roots, I need that to be greater than 0. Because this is the part that's underneath the square root in the quadratic formula. We need that to be positive. So I plug in my values. I know b is negative 2k squared minus 4. Well, my a value is 1. And my c value is also 1. And that has to be bigger than 0. And so when I do the square, negative 2 squared is 4k squared minus 4 is bigger than 0. Well, at this point I have several options to do. And I'm going to do a factoring kind of method. The first thing I'm going to do, I'm going to pull out the 4. And so this is k squared minus 1 is bigger than 0. I can divide both sides of the equation by 4, or the inequality rather by 4. And that means I'm left with k squared minus 1 bigger than 0. Now, to deal with that bigger than 0, that means positive numbers. I'm going to factor this a little further and think about k plus 1 and k minus 1, because I have a difference of squares here. Now, I'm going to think about this on a number line, where I know that this one will give me a value for negative 1, and this one will give me a value of positive 1. And I'm going to take those values and I'm going to put them on my number line. So here is negative 1, and here is positive 1. And I need to make them positive. To do it, I'm going to look at the different intervals. So here's the interval that's less than negative 1. So numbers like negative 2, negative 3, negative 4.521 all fit in here. And if I plug, let's say, one of those numbers into here, like negative 4, for example, if I plug negative 4 into here, negative 4 plus 1 gives me negative 3. And negative 4 minus 1 gives me a negative 5. That'll be negative 3 and a negative 5. 2 negatives make positive. That means everything in this region will be a positive number. If I look at this region here, I pick a number in that region, and the easiest one to pick is 0. And so I plug 0 in for k. 0 plus 1 is 1. And this is minus 1. So a positive times a negative will give me a negative value in here. So all the numbers in here will end up being negative on this calculation. And if I look at the positive ones over here, bigger than 1, so like 10, well, that's 10 plus 1 is 11, that's positive. 10 minus 1 is 9, that's also positive. So this is 2 positives, which will then make a positive. So if I consider my intervals here, so if I go negative 1 all the way this way to negative infinity, and positive 1 all the way this way to positive infinity. So in order for this equation to be bigger than 0, I have to have k be less than negative 1 or k bigger than 1. And that's how I can solve this inequality. Another method I could use, and let's just look at k squared minus 1. Another method I could use is if I have k squared minus 1 is bigger than 0. A lot of people in the test went k squared is bigger than 1. And then they took the square root of both sides. And they went k is bigger than plus or minus 1. Well, there's a rule that's seldom used in mathematics, but the true fact is that if I have x, the square root of x all squared, it's not actually x. It's actually the absolute value of x. But when it's an equal sign, we never need to worry about that, so we always just ignore it. But when it is inequality, you must put it, and so it's saying the absolute value of x is actually bigger than 1. In terms of a graph, that means distance away from 0 is bigger than 1. So that could be x less than -1, or sorry, k less than -1, or k greater than 1. There's a little bit of inequalities, and that's it for today.